Video, we're going to take a look at how to solve certain types of quadratic equation problems. Now, let's take a closer look at some problems. We'll start with problem number 1. A golf ball is hit from ground level. Its path is modeled or shown by the function h is equal to negative 4.9 t squared plus 30.6 t, where h is the height of the ball above the ground in meters and t is the time in seconds. Let's illustrate this with a diagram. The blue dotted line illustrates the path of the golf ball. We see the maximum height is the highest point on the x-axis. It hits the ground when you're back down at the y-axis at the end of the curve. And then we have the maximum height is at the middle of the curve. The question asks, for how long will the ball travel before it hits the ground? How long will it take for the ball to reach the maximum height? And what is the maximum height of the ball? These are the questions we will answer in this problem. To answer this question, you will need to rewrite this equation in vertex form. Y equals a bracket x minus h bracket to the exponent 2 plus k, where hk represents the vertex if a is negative and the lowest point if a is positive. Here is an illustration of our problem. Now, the math. Divide both terms in the equation by the number in front of the t squared, which is 4.9. H equals negative 4.9 t squared plus 30.6 t. Take the number 30.6 and divide by negative 4.9. This will give us negative 6.245. We'll move the negative 4.9 in front, so we will get t squared minus 6.245t. Divide the number in front of the t term by 2. 6.245 divided by 2 is 3.1225. Square this result. 3.1225 squared is 9.75. Add this value inside the bracket at the end as a plus value and a negative value. By adding both the plus and negative, you are not changing the value of the expression. You will get y equals negative 4.9 times, inside brackets, t squared minus 6.245t plus 9.75 minus 9.75. Continuing on, we've just reviewed step 4 again, so we have it available. For step 5, take the number in front of the bracket, negative 4.9, and multiply this by the last negative value in the brackets, which is negative 9.75. When we do that math, we will get 47.78. Rewrite the equation using this new value. Y equals negative 4.9 times t squared minus 6.245t plus 9.75 plus 47.78. Next, factor the expression inside the bracket by taking the square root of the last number, 9.75, the square root from the first number, t, and the sign from the middle term, and square the bracket. This would be written as negative 4.9 times t minus 3.1225 to the exponent 2 plus 42.78. Next, as we did in the previous slide, you factored the expression inside the bracket by taking the square root of the first term, t squared, the square root of the last number, 9.75, and the sign from the middle term. Write this in brackets and square the outside of the bracket. Now we're ready to move to step 8. Determine the vertex from this equation. So the value of hk, the vertex, is equal to 3.1225 for the x value, which is found from taking the number inside the bracket. Remember to use the opposite sign that's written there. And 47.78, which is in the k value position, the y value. Now that we've determined the vertex, we're ready to answer the questions. For how long will the ball travel before it hits the ground? Well, we know the distance from the origin to the maximum height was 3.1225, the x value in the bracket. But you still have to travel from the midpoint to the end, so you multiply by 2, which will then give you 6.245 seconds. How long will it take for the ball to reach the maximum height? 3.1225 seconds. And then, what is the maximum height of the ball? Which of course is the k value. So the maximum height is 47.78. Now, on to the next problem. Click on the next slide. Show.